Hello students, in this video we are going to discuss about some introduction part of what is EMF, that is the cell potential of a cell, and also we are going to discuss about standard hydrogen electrode, that is in short called as SHE. First, what is EMF or the cell potential of a cell? As we have already discussed about electrochemical cell, and electrochemical cell have two half cell. So that is, one is the oxidation half cell and the other one is the reduction half cell. So the two electrodes in these half cells have different reduction potential values. Therefore, they have different tendency to lose or gain the electrons. The electrode having higher reduction potential value have higher tendency to gain the electrons, whereas the electrons having lower reduction potential values have lesser tendency to gain the electron. So as a result, the difference in the electrode potential of the two electrode in electrochemical cell is represented by EMF. So EMF is defined as the difference between the electrode potential of the two electrode constituting an electrochemical cell is known as electromotive force, that is EMF, or the cell potential of the cell. Now how we find out the EMF or the cell potential of a cell? That is by formula. EMF can be found out that is equal to reduction potential of cathode minus reduction potential of anode. That is in the cell representation. In the convention, the electrode, that is the cathode, is written on the right side. Cathode is written on the right side and the anode is on the left side. So this equation can be written in this way, that is E cell is equal to E right minus E left, because on the left hand side anode is represented, that's why we can write this equation as E left, and because the cathode is written on the right hand side, therefore it is written as E right. So this formula can be, in short, it can be written as like this: E cell is equal to E cathode minus E anode, or E cell is equal to E right minus E left. Thus the electromotive force of the cell may be defined as the potential difference between the two electrodes of the cell when either no or negligible current is allowed to flow in the circuit. This EMF of the cell is measured with the help of potentiometer. So if we want to find out the EMF or the E cell potential, we want to subtract the reduction potential value of electrode, that is at cathode side, minus reduction potential value of anode. Since a half cell in an electrochemical cell can work only in the combination with the other half cell, that is, it does not work independently. That means in the half cell, that is in the cell will work only when the half cell is in combination with the other half cell. It does not work independently. So it is not possible to determine the absolute electrode potential of an electrode. So as we have to therefore find the relative electrode potential. So for this we have to use a standard electrode, that is actually the standard hydrogen electrode that is used in order to find a relative electrode potential. Now what is standard electrode, hydrogen electrode? In order to find out the relative electrode potential of an electrode, a reference electrode is used, that is universally accepted as a reference electrode. That is what called as standard hydrogen electrode, which is in short it is represented as standard S, H for hydrogen and E for electrode. that is standard hydrogen electrode, or it can be represented as a normal hydrogen electrode, that is written in short, that is NHE. So it can be represented as SHE, or it can be represented as a NHE, normal hydrogen electrode. So let us discuss about this electrode. Standard hydrogen electrode. It consists of a platinum wire which is sealed in a glass tube, and it has a platinum foil at one end that you can see here, which is coated with a finely divided platinum which act as a platinum electrode here. And this is all is dipped in a solution, and that is a acid solution of 1 molar concentration. The concentration of the solution is here taken as 1 molar. And the pure hydrogen gas that is constantly bubbled into the solution at a constant temperature, that is 298 Kelvin temperature, and the pressure of the gas is as 1 bar. So the hydrogen gas of 1 bar pressure is constantly bubbled into the solution, and that is at the constant temperature 298 Kelvin. So here this platinum foil, that is this platinum foil will act as a site for the reaction. So whatever the reaction will take place at this site. Now here let us define this standard hydrogen electrode. So what is the definition? And it is important because the definition will be asked in the exam. That is a standard hydrogen electrode, or SHE, is assigned as an electrode potential of 0 volt. The SHE is used as a reference to measure the electrode potential of other cell. In order to find out the electrode potential of any other cell, the standard hydrogen electrode is used as a reference. So in order to find out the electrode potential of any other electrode, we have to connect that electrode with the standard hydrogen electrode. So because here the standard reduction potential value for electrode potential value is 0 volt for this one. So by this we can find out the electrode potential of the other electrode. So what we can say that here this standard hydrogen electrode can act as both anode as well as cathode. So if it is acting as a anode, so what will be the reaction here? The reaction will be H2 is giving rise to twice H plus plus 2 electron, because what we have learned that the reaction at anode is oxidation. So the hydrogen gas which is bubbled, so at the site of reaction, that is at the platinum foil, it will loses the 2 electron and it forms 2 hydrogen ion. So what will be the reaction? That is H2 is giving rise to twice H plus plus 2 electron. So this is the reaction what takes place if the standard hydrogen electrode act as anode. But in some case it will act as a cathode. At the time we know that at the cathode means the reaction is a reduction. So at that time what happened? The 2H plus, that is the solution having H plus ion, it will gain the 2 electron and it give rise to hydrogen gas. So this reaction, because here gaining of electron is taking place, this is a reduction reaction. So these are the two reactions which is possible for the standard hydrogen electrode. If it is acting as a anode, this reaction takes place. If it acts as a cathode, this reaction takes place. When the standard hydrogen electrode is connected with the zinc, that is here the zinc electrode act as an anode and the standard hydrogen electrode act as a cathode here. Now here the condition are taken in the standard condition, that is the concentration is taken as 1 molar concentration. Now in this case what will be the reaction, because here in the case of anode, as we have discussed, oxidation takes place. So the reaction will be, that is Zn is giving rise to Zn2 positive plus 2 electron. And here because it will act as a cathode, so the reduction reaction takes place at cathode, that is hydrogen ion plus 2 electron is giving rise to H2. So here what is actually happening here, the 2 electron which is lost at the anode is gained in the cathode, that is it is gained, and the reaction takes place in such a way. So here there is a flow of electron in this direction. So definitely there will be flow of charges, means definitely there will be a current. So it will show a value here, that is in the potentiometer it shows the reading 0.76 volt. So that is what actually cell potential here. So that is E naught cell value we are getting from this reading. So here that is E naught cell, we are using the formula E naught cell, that is naught value we are using, that is for the standard condition. So E naught cell is equal to E naught cathode minus E naught anode, and here we got the value 0.76 volt when we have taken both the electrodes in the standard condition. So after connecting this one, we are getting the value 0.76 volt here. So at the time here we will be substituting the value 0.76, that is E naught cell value, because here E naught cathode, it is a standard hydrogen electrode, and we have learned that the value for standard hydrogen electrode, the reduction potential value is 0. So that is kept 0 here. And for anode we have to find out the reduction potential of zinc, that is unknown to us. We are keeping question mark for this. So we are finding out E naught anode here. So we get the value, that is the value is E naught anode is equal to minus 0.76. This is the value what we are finding out, that is the reduction potential value of zinc. That is, we have find it out in reference with the standard hydrogen electron, that is minus 0.76 volt. But in some cases the standard hydrogen electrode act as a anode, like in the case of copper. In the case of copper, it will act as a anode. So what will be the reaction when it acts as an anode? The reaction will be H2 is giving rise to twice H plus twice electron, and here the copper electrode, here the reduction takes place. So the reduction reaction, that is copper ion plus 2 electron giving rise to copper. So it means here the 2 electron which is lost in the anode is gained in the cathode here. That means the flow of electron will be in this direction. That means the flow of current will be in the opposite to that. Here the reading is shown, that is 0.337 volt. That is approximately taken as 0.34 volt. So that is what is the value of E naught cell. E naught cell value is this reading, and this is the reduction potential of cathode, and here is the reduction potential of anode. Because here we are keeping the standard hydrogen electrode at anode, because it will act as an anode here. So the value of E naught anode is 0, because it is a reference electrode having a reduction potential value 0, and because we have to find out E naught cathode, because this we have to find it out. So we will be substituting the values here. E naught cell value is equal to 0.34. E naught cathode, that we have to find it out. I have written as E naught C here, and E naught anode, that is 0 value. So when we solve this one, we get the reduction potential for copper, that is we got here the value as E naught cathode is equal to 0.34 volt. So we have find out the standard reduction potential for copper. We have find out the standard reduction potential for copper, that is 0.34 volt. That is positive value. That is by connecting the copper electrode with the standard hydrogen electrode. That's why we have used the definition for standard hydrogen electrode as it is a reference electrode. How we have defined the standard hydrogen electrode? That is it is a reference electrode which having the potential value standard potential value as 0 volt. It is used as a reference to measure the electrode potential of other cells. So that is why in this video we have explained the two cases. We have find out the reduction potential of the, that is electrode potential of other half cell by connecting that with the standard hydrogen electrode. Now in this table, the E naught values of different electrodes are given as it is shown in this table, and you can see for the hydrogen electrode, that is standard values, that is E naught value is given as 0 here. That is it is given here. Now in this case we can see there are positive values above to 0 and there are negative values below to the 0. That means the values which is getting more positive, that means we can say that increasing the strength of oxidizing agent. So on the basis of the E naught values we can find out whether the given electrode is a more oxidizing agent or not. And we can see that here top to bottom we can see the values are decreasing, and we can say that there is increasing the strength of reducing agent, that is from here to here. So when we compare the values which is at the bottom, that will be have greater strength of reducing agent than the electrode which is there at the top. But the electrodes which are at the top, they are have greater strength of oxidizing agent, and the bottom one have lesser strength. So when we remember this concept, that is we can say that top to bottom, that is the value is decreasing, E naught value is decreasing. That means the increasing the strength of reducing agent, and from here to here is increasing the strength of oxidizing agent. So by using this we can have different questions. On the basis of this we can give its answer. So this is all about this video. Have a nice day.